In this first chapter of Core Pure 1, we're going to introduce complex numbers. So in order to try and work out what a complex number is, we're going to look at some different types of number systems. Or some different sets of numbers. So an equation such as 10 plus x equals 4 needs a natural number to solve it. And a natural number is a positive integer. And we often use the letter n written like this to represent the set of natural numbers. Well, you can think of an equation where you need more than just the natural numbers to solve it, such as x plus 5 equals 3. We obviously need a negative number, minus 2, in order to solve this equation. So if we take the set of natural numbers and we add in 0 and the negative integers, then we get the set of integers, which we call z. You can also think of some equations where you need more than just the integers to solve it. So for example, x squared equals 2. We need an irrational number, root 2, in order to solve an equation like that. Or 2x equals 1. We're going to need a fraction that's not an integer. We're going to need a rational number. So if you take the set of integers and you add in the set of rational numbers and irrational numbers, then you get the set of real numbers, which we often denote by r, written like this. And all the equations that you've met so far in A-level maths have had a real number solution to them. Well, in this chapter, we're going to introduce the set of complex numbers. An example of an equation where you need a complex number to solve it is x squared equals minus 4. Well, the reason why there's not a real solution to this is because when you square a real number, you can't get a negative solution, a negative answer. When you square a real number, you always get a non-negative answer. So we're going to have to invent a different type of number called a complex number in order to solve an equation like this. All complex numbers are based on the imaginary unit, which is I. And you can kind of see what the imaginary unit is by thinking about this equation, x squared equals minus 1. Well, we don't have a solution at the moment to this using just the real numbers. So what mathematicians did is they just invented a constant which they call I. And I is the solution to this equation. So if we say the solution to this equation is x equals I, and I, this solution, is often referred to as the imaginary unit. So you can think about I is I squared is equal to minus 1. That's the definition. Or another way of thinking about I is equal to the square root of minus 1. So that's the definition of I. And in this chapter, we're going to be working with this number I. So let's look at the what a general complex number looks like. So you'll often see the letter Z used to represent a complex number. So if it's a real number, you often use x. If it's a complex number, you'll often see z, although you could use any letter you wanted. So we've got a complex number here, z equals a plus b times I. And here we should probably write a and b are both ordinary real numbers. So you can see that the complex number has two parts to it. You've got this part, which is a, which doesn't have I in it. And this is what we call the real part of the complex number. So the real part of the complex number is a. And then we've got this term here, bi, which has I in it. And this is called the imaginary part of the complex number. But the imaginary part is just the coefficient of I. So in this case, the imaginary part is b. So to make the complex number, we've got the real part, a, plus the imaginary part times by I, so bi. A shorthand way of writing this would be to say the real part, re, of z is equal to a, and a shorthand way of writing the imaginary part of z would be to write im z equals b. So let's look at this example of this complex number. We've got this complex number z1, which is 2 plus 6i. Let's write down what the real part and the imaginary part of this complex number is. The real part of z1 is the term without I in it, which is 2, and the imaginary part of z1 is the coefficient of I, which is 6. This is a slightly more difficult complex number, slightly more complicated. Often what we do when we've got a complex number with multiple terms in it is we try and make it look like this. So we're going to collect together the real parts without I in them. So we've got 2 and minus b are the two terms without I in it. So we could write that as 2 minus b. And we could even put it in a bracket to make it clear that that's the real part. And then we're going to take I outside of a bracket, outside of these terms with I in it. So we could write that as plus 6 minus 4a multiplied by I. And writing the complex number in this way makes it really clear that this part here is the real part, and this part here in a bracket is the coefficient of I, which is the imaginary part. So real part of z2 is 2 minus b, and the imaginary part of z2 is 6 minus 4a. And again, notice that this real part hasn't got I in it. It's the imaginary part, is just the coefficient of I. So before we look at example 1, what I want you to do is, with these three complex numbers, see if you can find out what the real part of z is and what the imaginary part of z is. And once you've done that, you should get these answers. And again, remember that the imaginary part is just the coefficient of I. It's not got I in it. Let's look at example 1 then. So we've got these two numbers and we're asked to write them in terms of I. So what we're going to do is we're going to split root minus 36 up into two surds multiplied together. And we're going to use the surd law that we can split that up into root 36 times by root minus 1, because we could combine them into a single surd, root minus 36. Well, root 36 is just a real number, that's 6, and we know that I is equal to the square root of minus 1, that's the definition of I. So we could write that as 6 times by I. Similarly, in part B, we could split that up into root 28 times by root minus 1. Root 28 is 2 root 7, and root minus 1 is just I. Now notice that these complex numbers look like they don't have a real part. They've just got an imaginary part, which is 6. Well, you could write this complex number, if you really wanted to, as 0 plus 6i. Or you could write this complex number as 0 plus 2 root 7i. So actually here, you can see that the real part is equal to 0. And same with this number here. Complex numbers where the real part is equal to 0 are called purely imaginary. Similarly, there's purely real numbers. So an example of a purely real number would be 6, because you could write 6 as 6 plus 0i. So here we've got the imaginary part is equal to 0. So these are just ordinary real numbers that you're used to working with. So every real number that you're used to working with is actually a purely real complex number. So for example, if we had root 2, we could write that as root 2 plus 0i. The imaginary part is 0. So these are called purely real.